Hello, my name is Cecily Holland, and in this walkthrough, I'll be presenting my assignment 3 for machine learning, intro machine learning 5410. In this assignment, the goal was to build an image upscaler using convolutional autoencoder that takes a 28 by 28 grayscale image of a dog or cat and outputs an upscaled 56 by 56 version. The project focuses on learning the structure of images rather than classifying them, since we have dogs and cats available in our training and testing data. So for part one, we are loading and pre-processing the data here, and then this is where we're determining the directories. I have the folders match here. You can see all of the cats, and in this folder it's all numbers, but all of the ones in the test folder are dogs. So I loaded the data set from the front folders, converted each image to grayscale for simplicity and better performance. And we did that in here, resized them, and then converted them. And each image is resized twice, actually, once onto 28 by 28 for the input and once to 56 by 56 for the target. I also normalized the pixel values to be between 0 and 1, and I added an extra channel dimension since Keras expects a 4D tensor for image input. And all of that's happening in this load data function. For part two, we are determining are building the convolutional autoencoder using TensorFlow and Keras. The autoencoder consists of two conv2D layers with ReLU activations and max pooling layers that reduce the input from 28 by 28 down to 7 by 7. The decoder then reconstructs the image by upsampling from 7 by 7 back up to 56 by 56 using the upsampling 2D layers and conv2D layers. The final output layer also uses a sigmoid activation to keep pixel values between 0 and 1, and I used binary cross entropy as the loss function. And that is happening here, the model summary, and then there's the autoencoder. And then training the model. We use the 50 epochs and a batch size of 128, and the training and validation steadily decreased over time, and I saved the final model to an HDF5 file for later use. The results in visualization, this is just printing. For results in visualization, we are testing the model on a sample from the test set, and on the screen you can see these three images as the outputs. The original 28 by 28, the generated 56 by 56 in the middle, and the actual 56 by 56 ground truth on the right. And while the generated image is slightly blurry, it captures the main structure and shape of the original image, which is expected with this type of model. Overall, the assignment helped me to better understand how convolutional autoencoders can be used for tasks like image upscaling and how to track feature dimensionality throughout a deep learning model. Thanks.